let's just go through it. It says the interest rate is 13% and you borrow $6,000 for a used car. So it says, hey, what is your monthly payment? So how do you do that? 6, right? So 6 is right about there. And then what do you go up to?
No, isn't it 13?
Oh, 13. I'm reading it backwards, yes. So 13 is right there. 6,000, so you go up to 6,000 is like right about there. So what do we think it's about?
About 140 or something.
Around 140,000, right? Does that make sense?
140,000 or 140? That is
Monthly payment, so it's 140. Sorry, yes, it is monthly. Yep. Okay, there's the first one. So our monthly payment is 140. So it says if interest rates were at 11% right there, how much more can you borrow without increasing your monthly payment? So if you're at 140 now, if you're keeping that the same, you need to stay at what? 140. No, you need to stay. You need to stay at 140 to stay. The monthly payment is 140. They're saying you're staying at the same monthly payment, so you're staying at 140. So you need to stay on the same contour line. So therefore, they're asking you to go up to that and then go back to, as Ali said, about what? I mean, that's not. Yeah, let's just say it goes right there. So around what?
6.5.
Yeah, around 6,500. Does that make sense? Loan. Yep. So what do we know right now? So if you had 140, the first one was 13%, and the other one was, the loan amount was $6,000, right? And then we did 11%, and what was that? 6,000 what? 500. So they just want you to plot some more points. That's all they're asking you to do. No, does it say how many points to plot? How many points to do? No, so you could do 4 or 5 more. I mean, maybe do the ones that you can estimate nicely, but maybe do 9, 7, 5, 4, 1. Can't really do 1. Why can't you really do 1 on that case? It doesn't really tell you. I mean, you could like estimate this thing goes up like that, right? Do you understand how to fill that in? Just go backwards? Okay. For each of the questions 1 through 4, draw 2 cross sections with pizza fixed, 2 cross sections with cola. Yeah, so here's the 2 axes right here. One of them is pizza and one of them is cola, right? So it says 2 cross sections pizza fixed. So if you fix pizza, you're drawing whatever the cross sections are at that. Like, so let's say we fixed the value like on this one right there. What would that cross section look like? It would be the path at that fixed value right there. There's your cross section right there with pizza fixed. And then what would the cross section look like with cola fixed? Let's say we fix the cola value right there. It would be another one like this. It's kind of hard to see the surface, right? But let's say we zoom in on this one right here. If we fix pizza, on this one, like there's a pizza value, right? What's the cross section look like? Like you go up to that value, and what is it going to do? It's going to go woo, and then back down the other side like that. And then this one right here is going to go woo, and then back down the other side.
Yeah.
Do you kind of see that, everybody? So you do that the other direction as well. That's what it's asking you to do.
So what is that?
For this one, what do we already have? We have the unit vector. Does that happen to already be a unit vector?
Yeah.
It does. Very nice. You use that actual picture. So how do we do that? Find the point. Good. I love that. Find the point. No, that's true. It's actually sometimes not true, but find the point 3, 1. Where is it? Right? Is that it right there? Okay. That's the point 3, 1. I like that. Now what? It's making a sketch of what? Gradients? So how do you find the gradient of one of these? Like for A, what is the gradient for A? Yeah, you do all the partials. So what's the partial with respect to X? What's the partial with 2y and 2z, right? And then it's asking, so that is the gradient at any point. So if you put in a point 1, 1, let's say you're at the point 1, 1, 1, what is that grade? It's gonna be 1, 1, 1, right? 2, 2, 2. Sorry, 2, 2, 2, and then it's 3, 3, 3, and then it's 4, 4, 4, and then it's 5, 5, 5, depending on what you plug in. Or so which one? What is it like at the? Yeah. So which one points radially out from the?
Origin.
Does it point out from the origin? You sure? I think I agree with you. You just have how many? You have to think of it in 3 space because this is in. What space are we in? We're in 3 space right now.
No, yeah.
I agree. I'm saying I agree with you. I just wanted you to be sure. I need to think about it as well. It's not always that easy. Like in the first quadrant, if all the values are positive, then it does make sense. Well, so that would be like this octant right here, right? Like there's that octant we're in, right? So if all of them were positive, it will be going out. If all of them were negative, they'd be going the opposite direction. So I think this one's going to be point radially outward from the origin like this. What about B here? What about for this one? This is what? 2x and 2y. What's not there?
The Z.
There's no z value, so which one's that one going to be? Radially outward from
Z axis.
the z-axis, right? So this one's B right here, and this one is A. And then do you do similar things for the next two?
Yeah, it's just
Yeah.
those are negative.
There's a negative, right, exactly. So you could think about it that way, that's fine. 3, right? So if you have two vectors right here that define, two vectors right there, if you want to find the area of this parallelogram, what do you do with these two vectors? A cross B, right? So you do A cross B. But then if you have a third, let's say you had a third vector like this, that turns it into this three-dimensional parallelogram like that. Does everybody see what I'm trying to draw right there? How do you go, what do you do if that's vector, let's say C right here? So you have vector A, B, and C. A cross B is what type? Is that a vector or a scalar? A cross B is a
A
vector. A cross B is a vector, right? And then what do you dot it by? Dot it by C, exactly. That's the scalar triple product, right? Because this is a vector and this is a vector, but when you dot two of them together, but if you just wanted the area of A and B, of the parallelogram divided by A and B, what would you do? If you just wanted this area right here, the base.
Just A cross B.
No.
A
The
dot
dot.
B divided by 2.
Which one is it?
The magnitude.
We just used it at the beginning. The gradient of f at what? P dot what?
Unit vector.
The unit vector, w, like that. Dot w. So let's say we don't, just making sure that that's a unit vector. Oh, come on! Root 3 over 2. And what's sine of 30 degrees? 1 over 2. And luckily, what is that? Not luckily, but very much on purpose. It's a unit vector, so it's already unitized. Are we okay with that? That's a terrible word to say out loud, I guess. Okay, so we have the easy value, right? But what's the one we need to find? We need to find the gradient of P. So we know the direction, right? What's the direction of this going to be? We know it's going to be some value dot what, comma what? What direction is the gradient going in? It's this purple vector, right? We put it on the x-axis, right? Is this thing going up or down like this? No. So what does the j coordinate need to be? It needs to be 0. Are you with me so far? It has to be 0. We're okay with that? But what do we know? We know that at any given point, remember earlier in the day when we looked at that chart right up here, how did we find this gradient? What did we do? The partial of x at xy and the partial y xy. Are you with me like on that one? Okay. Got it. So we know on this one right here, that from the side, what does this look like? We know we're going in the x direction, right? You with me so far? What's the angle measure? No, it's 20 degrees, right? It's 20 degrees. So we have this, why is this stuck? The button gets stuck. And we know that this is 20 degrees, correct? So we need to find this right here. So for every, this is what it's going in, right? We need to actually find, this is the one we want here. This vector right here is this one, this magnitude right there, right? That's the x direction. So this is looking from the side, right? If I was looking straight down, that's the purple vector right there. But we want this distance. How do we find this distance? How do we find that one? What is it?